Okay, we'll continue now. This is the second part of 9-1. We ended with the example of 12 to the power of 2/3. And we realized that it's the most that we can simplify that when converting to radical notation, which you have in your notes from the first part, it'd be 2 times 18 to the power of 1/3, or as we wrote, 2 times the cube root of 18. Okay? All right. So next example, I'm not sharing the screen there. Thought I was, but not. Hopefully you saw that on your notes. For the next example, come on. Okay, we have negative 27 to the power of 2/3. Okay. Now, this is why I mentioned previously that this could be, let me scroll up, okay? When I mentioned it's been a while. Wait, where was it? Oh, I guess it was right here. So notice that a to the power of m, the nth root of that, is also the nth root of a to the power of m. All that to the power of m. So I'm going to use that. So I'm talking about what's up there on your screen. What screen, not screened, that's highlighted, and then with an arrow showing another way to express that radical notation. So just in case, this is equal to negative 27 to the power of 2, the cube root of that, or we can see that as negative 27, the cube root of that, all of this to the power of 2. So you could do either one of those. If I do negative 27 squared, I'll get 729. So for that, you would need a calculator and the cube root of that, and that will be equal to 9. However, with this other method, this one might be, when I say this one, I mean this one over here. Might be more intuitive for us. I'm looking for a number that multiplied by itself 3 times will be equal to negative 27, and that number is negative 3. And negative 3 squared is negative 3 times negative 3, which is equal to 9. So we get to the same place, but we don't have that 729 there, okay? So you could do either one. Sorry, just gonna email something about my daughter. Give me 1 second, I apologize for this. My apologies. Okay. So yeah, either way works, but we don't have to deal with the 729. Now 81 to the power of negative 3/4. When I have a negative, and we've seen this before, like x to the power of negative 1 is the same as 1 divided by x. So this is the same as 1 divided by 81 to the power of 3/4. So the inverse, and then we don't have that negative anymore. As we learn with that a and m and n, this is the same as 81 to the power of 3. And the 4th root of that. But similar to the previous example, if we do 81 to the power of 3, I'm just going to make sure I don't get any messages because it's distracting even though it's important. 81 to the power of 3 is going to be a huge number. So this is also equal to 1 divided by the 4th root of 81 to the power of 3. So a number multiplied by itself 4 times equals to 81. 3 makes that true. 3 times 3 is 9 times 327 times 381. So here I have 1 divided by 3 to the power of 3. And on my notes, I wrote 1/9. That is not right. My apologies. This is 1 divided by 27. Okay? Let me see. Let me check my notes that if that's what I posted. And yes, sometimes I mess up and I am sorry for that. Yes, I posted 1 divided by 9 and that is terrible. It's 1 divided by 27. Okay? All right, our next examples now have variables. Okay. Now I have variables. So the first example, I have this here. I have the square root of w multiplied by the cube root of w. It's like, oh my goodness. So when we get to this, it's more convenient instead of having radical notation to have rational exponents because we know how to deal with rational exponents. What do you mean you don't know how? Yes, you do. So here I have w to the power of 1/2. If I change this, I'm going to scroll using that notation. See what I have up there that is highlighted. Notice how often I've been using that now. I have w to the power of 1/2, w to the power of 1/3. Now I know that when I'm multiplying the same base and I have different exponents, I end up adding my exponents. So we have 1/2 plus 1/3. And because we are experts at this time finding a common denominator, if I find a common denominator for 1/2 plus 1/3, common denominator will be 6. If I do the process, I'll get w to the power of 5/6. I'll just do that briefly here just in case. You don't have to write this down. 1/2 plus 1/3. Common denominator is 6. Here I will have to multiply by 3/3. So I would 3/6. Here, multiply by 2/2, so I would have 2/6, and I add the numerator, same denominator, okay? Like, no, don't erase that, well, you can pause, right? So I have w to the power of 5/6, or w, that color is very, I'll say demure and all that, but I'm not going to say that. This is the same as w to the power of 5, the 6th root of that. Okay, so either this way or this way will be fine, depending on whether the problem is asking you for rational notation or, sorry, radical notation or rational exponent notation. Okay. Example B, so many examples here. I have 16x, the 4th root of that, divided by the cube root of x, okay? All right, so this is the same as finding 16 to the power of 1/4, and x to the power of 1/4 because of what I highlighted up there every time I scrolled when I'm changing from radical to rational exponent notation, and I have x to the power of 1/3 in the denominator. 16 to the power of 1/4, it means what number multiplied by itself 4 times gives me 16. That will be equal to 2. Then I know that when I'm dividing something like this, x to the power of 1/4 divided by x to the power of 1/3, it means I subtract the exponents, okay? 1/4 minus 1/3 as the exponent of x. 1/4 minus 1/3, they really want us to practice here using the least common denominator and so on. Just in case you're wondering where this comes from, I get 2x to the power of negative 1/12. Then if I want to express this as a positive exponent, I get 2 divided by x to the power of 1/12. And if you want to express this as radical notation, it's x root 12 of that, depending if they ask you rational exponent, radical notation, okay? So the key here was, as you can see here in the highlighting, here knowing that the 4th root of x is x to the power of 1/4, which you see up here in what I highlighted, which is key, okay? We're going to see two more examples and we'll see how far we get. C, I'm looking for the square root. That square root is inside the cube root. So that's something. That's definitely something. So I'm going to take this thing that's highlighted here first. That is m plus 1 to the power of 1/2, right? Square root will be the power of 1/2. Then, we highlight the different color. I'm going to take care of this one over here, the cube root. And that is all of this expression that I have here to the power of 1/3. And we know that when we have exponents 1/2 to the power of 1/3, or like a to the power of b, to the power of b. For the exponents, we multiply them. These rules that we saw before. That means that this is m plus 1 to the power of 1/2 times 1/3. We don't need a common denominator when we have something like that. So this is multiplying 1/6, 1/2 times 1/3 will be 1 for the numerator, 2 times 3 for the denominator. This is m plus 1, the 6th root of that. Okay? So you have this for rational exponent, this for radical notation. Example D, lots of examples, so hopefully it makes sense. I have c to the power of 15. I'm looking for 5th root of that. So looking at what I highlighted up there, this is c to the power of 15 divided by 5, c to the power of 3, which we cannot express now in radical notation. You can, but you will just have to make bigger the radicand to make it even bigger. The exponent of the never mind. We just leave it like this, okay? My bad. I'm trying to cover everything. We'll see. Just let me know if you have any questions, okay? For the next topic, okay, we can combine radicals. Writing everything is going to take a while, but this is what we have to do. So this is on the notes and also on the handouts, so both the handwritten notes and the handouts. We can combine radicals if, okay, the first one, the index must be the same to combine radicals through multiplication or division. We'll see examples, and hopefully it makes more sense when we see examples, okay? So the index, you want to scroll? Like, no, why scrolling? It's just affecting, ruining everything. Index was n out here. So for square root, for example, that will be 2, okay? So the index must be the same. Try to figure out why I'm being so loud if, you're right there. This is a computer, you're right there. Must be the same to combine radicals through multiplication or division. I don't like to do this, but gotta move on. I just say the total of 2, no, 1 second, okay? All right, so the index, remember that is outside of my radical. Now the index and the radicand must be the same to combine them through addition or subtraction. And we don't really see examples of that. So you can take a look at in your handout is there. If you're following the handout, the index, just remember that you don't have to write this down. This is the index and this is the radicand, all right? So if you are doing addition or subtraction, both of them have to be the same in order for you to combine. But we're going to see examples of just the first one. And again, the second one is on your notes. So what I just said, you can write it down as I say it, or it's already on the notes and in the handout, the index and the radicand. So N and A both have to be the same to combine the radicals, 2 terms, for addition or subtraction, okay? So examples, so we'll see 2 examples. And then I wanted to go over homework examples, but we won't have time to do that. However, you can always come and ask me. Always come and ask me, okay? I'm available. You can come and ask me anytime. You can even ask me during the tests, during the quizzes. I'm here to help, okay? Now here, the index of each of these radicals, radical, or sorry, the cube root of 2a, the index is 3. The cube root of 5a, the index is also 3. That means that I can combine them all and say I have the cube root of 2a times 5a. I can combine them because they have the same index. I say the cube root of 10a squared. And I don't think we can simplify that anymore. There's no number, or in this case, constant multiplied by itself 3 times, unless we're dealing with decimals, and no. There's no number or integer here, multiplied by itself 3 times, that will give me 10. And same with the variable here, okay? But this will not be the case for example B. That's why I was hesitating here. So here I have the 5th root of 4x divided by y. And this is the pinnacle of the problem. With this we end. We have the 5th root of 16xy. And I have the 5th root of xy. Everything has, why are you not scrolling? Everything has 5th root. So I can just say, all right, I put everything, I'm going to exaggerate 5th root. I'm going to have everything that's in the numerator, put it in the numerator. Everything that's in the denominator, put it in the denominator. I'm going to combine everything because it all has the same index. The index is 5 for all 3 of these radicals, okay? I have 4, I have x, 4x, and I have 16x, y. Woo, let's put them all here. 16x and y. What do I have in the denominator? Make it green in the denominator. Y, x, y. Ugliest y ever. X and y. Now I can start canceling things out. This is beautiful. Y cancels out. X cancels out. I guess that's it. So then I get the 5th root of 64x divided by y. And I take care of 64. Take care of it. I take care of 64. I can say this is, you know, the prime factorization tree. I get 2. This one's done. I'm not gonna go lower anymore. 16 and 2. This is 4 and 4. 2 and 2. 2 and 2. So I look at the bottom of each part of the tree, I get 2, 2, 2, 2, 2, 2. I have a bunch of 2's, right? I have 1, 2, 3, 4, 5. I have 5 of them. Do I have 6? I have 1, 2, 3, 4, 5, 6 of them. 6 of them. So then I say, I can even write all of them here. 1, 2, 3, 4, 5, 6. X divided by y. And I'm going to take 5 of them out. 1, 2, 3, 4, 5. 5 of them out. Because if I say 2 to the power of 5, and then the 5th root of that, it would give me 2. 2 is being multiplied by itself 5 times. So only one of them comes out. So 2 to the power of 5. 2 multiplied by itself 5 times. The 5th root of that is 2. And still inside of my root, I have 2x divided by y. This is a 5 over here, not an s. So again, this is important, okay? When I have something like this, you don't have to write this down. I don't know what I'm doing. 64, like what I just did. Okay, this. Then I have 2 here 6 times as we figured out. So only 5 of them. Okay, if I have 2 to the power of 5, the 5th root of that, then it will give me equal to 2. Okay, I take 5 of them out. They become 1, 2. This is important because you might have something like this. I don't know if you have it in the homework. If you have something like this, x to the power of 6, y to the power of 3. Let's do z to the power of 4. Okay, here, x to the power of 6 divided by 3 is x to the power of 2, right? Y to the power of 3 divided by 3 is y. Okay. And then I have that z to the power of 4 is z multiplied by itself 4 times. So 3 of them. I would have z to the power of 3 times z. So this one gets out of the radical. All right, so this will be equal to x to the power of 2, y, z, and then the cube root of C because I couldn't get one of them out. Okay? A little tricky, this last part, I know it's a little tricky, and this is on your homework, so let me know if you have any questions. It's a lot of material. The homework has, yeah, it's tough, but I'm here, as I said, and I can answer any questions that you might have. And I hope I recorded this because this was a lot. I was recording. Let me know if you have any questions. Thank you.